Welcome everyone. Today we are going to talk about solubility. And when we are talking about solubility is the maximum amount of substance that is expressed in grams that can be dissolved in a specific solvent. So if you are having your solvents can be water, it can be anything at all. So your solvent can be either water or it can be an organic solvents such as chloroform. So if you are having a water or an organic solvent such as chloroform and you dissolve some amount of solute inside, when we are talking about solute is actually the substance that dissolves in a solvent. So if you are having a solute and this solute is expressed in grams and it is dissolved in a specific solvent at a specific temperature, then we refer to it as what? As solubility. So solubility in all is related to what? Concentration. If you're having concentration and solubility. Concentration and solubility, they are almost the same, such that the only difference between concentration and solubility is that for solubility, it occurs or it happens at a specific temperature because there are several types of solutions. So types of solutions. Types of solution, we are having saturated solution. We are having unsaturated. And we are having supersaturated. And we are coming to take all these types of solutions one by one and know what goes into these types of solutions. So, when we talk about solute is a substance that dissolves in a solvent. And we are talking about the solvent itself. The solvent is the medium which dissolves the solute. And solution itself, solution is more like solvent plus your solute. So if you are having a solute and you dissolve it in a solvent, then you get a solution. And under this, we are having different types of solutions under this topic, what we refer to as the solubility. So now let's delve into how the solubility works and talk about the different types of solution. So now, as we are starting with, let's start with the unsaturated solution. So for unsaturated solution, assuming you are having a specific solution, let's consider this one as a sugar solution. Sugar solution is just obtained by dissolving some amount of sugar in, let's say, water or a solution, which can be an aqueous solution, which can be an organic solvent or all those stuff. So if you're having a sugar which has been dissolved in, let's say, water, then you get a sugar solution. Or if you're having a salt which has been dissolved in water. Now, if you're having small amounts, if you dissolve small amount of this sugar in the solvent, then we say that the solution itself is unsaturated because you can still add up some amount of sugar into this solution and yet this sugar will dissolve, or the extra sugar that you've added will still dissolve. For that matter, for unsaturated solution is a solution that can still dissolve extra amount of solute when it has been dissolved in it. Yes, and for the saturated, solution, you are having your solution all right, but you have dissolved the amount of solute. You have dissolved it into the solvent in a way that the solution can no longer absorb, or the solution can no longer dissolve the extra amount of solute that you are adding. And that is what we refer to as the saturated solution. So at this particular point, you are having your sugar dissolving fully. So extra amount of sugar or extra amount of salt that you add to this particular solution is not going to dissolve, but it's going to settle beneath the solution. You are going to see this particular solute that I've added. Now, in the molecular level, in a molecular level, it doesn't really show that there is some extra amount of solute that has been deposited beneath the solvent, but rather the extra solute that is added have been dissolved, whilst the dissolved salt or the dissolved sugar that was already inside the solution is now precipitating out. So as time goes on, we are going to talk about the term what called precipitation. The precipitation is simply the process or the situation where we are going to have some of your dissolved solute coming out of the solution due to some incident. So when we get there, we are going to know the factors that leads to the precipitation, and there are a lot of things. For instance, in terms of separation of, let's say, substances or purification method, we are having a method called what? Recrystallization. And this recrystallization, it deals with what? Precipitation of substance. So if you are precipitating it out, it comes in its pure form. So there's a way of what? Purifying substance also using the recrystallization. But now our main focus is on what? Is the types of solution, where we are having the saturated, the unsaturated, and the supersaturated. So for the supersaturated, solution, this is a type of solution which cannot absorb or which cannot dissolve any sugar or any amount of solute that you add. It can't dissolve any extra solute. For that matter, any addition of the solute that you add to it, it comes what? It deposits what? Below it. And if you continue increasing the solute content in this particular solvent, then you are increasing the volume. For instance, if you're having a small cup of solution, let's say this one is a small cup of salt solution. Now, if you add another extra cup of full sugar into this particular salt solution, remember that the volume of this is going to increase, because now the solution can no longer dissolve extra solutes, but rather all what it can do is that it's what the extra solute that has been added will rather increase the volume of this particular salt solution without dissolving it. Now, remember that as you are talking about solubility, the key difference between the solubility and the concentration is all about temperature. Remember that within the particular temperature or with a specific temperature, we can either have a saturated solution becoming unsaturated or a saturated solution becoming supersaturated, depending on the solution. So that is the main difference between it. So now let's try and talk about some factors that affect a solution. So now, there is a particular daily activity that usually happens, but we don't really take it into consideration what is really going on. For instance, if you are having a salt solution, let's say you are having a soup. If you're having a soup and you are boiling the soup, you tend to add some amount of salt into this particular soup, and you don't really taste the saltness of this particular soup. But when this soup cools down, after you've added extra amount of salt to an extent that you feel like it is okay, when this soup cools down, then you are going to have the temperature also decreasing, because if you are saying something is cooling down, the temperature is decreasing. So as the temperature decreases, that's when you are going to fill extra salt. As the temperature decreases rather. Remember that if the temperature should decrease right now, you are going to fill most of the salt that you actually poured into this soup. So this is a typical example of solubility. If you are adding extra salt to this, remember that you've not reached the saturated point. So the more you continue adding the salt to an extent that you feel like it is okay, the moment it starts cooling down, the point where you are having your saturated solution, now the moment it cools down, then you start getting super saturated, because some of the salt will now be precipitating out. So if it is precipitating out, you are going to get an increase in the salt content at that particular temperature. But the moment you start heating it again, then this salt that has been deposited will then start dissolving again. So remember that temperature is also temperature is a factor that affects the solubility of a particular substance. So always keep in mind This is a typical example. You can take a test tube. If you're having a test tube with, let's say, water, and it is at a specific temperature, let's say this temperature is at 25 degrees Celsius. Then, if you add some amount of salt, this salt is going to dissolve. If you continue adding it to a point where we are saying that the solution has reached its saturated point, where you can't add extra amount of salt to it, then at this particular point, we are saying that this solution is saturated. If you continue heating it, now if you start heating the solution, the salt solution, you are going to realize that the saturated point that you are having is now hot, becoming unsaturated, because the solution can now dissolve extra salt content that you add, or it can dissolve extra salt that you add to this particular solution. Now, the more you continue adding it, then the more what a saturated point what it becomes. So at this point where you've added more of the salt to this particular solution and it has dissolved. If you start cooling it up to 25 degrees Celsius, you are going to realize that some of the salt, the extra salt that you are talking about, or the extra salt that you really added, it is now precipitating out as the temperature cools, or as the temperature comes down, or as the temperature decreases. You are going to realize that some of this salt is precipitating out. So that is about solubility. So now let's try and talk about the solubility and temperature curve, the relation between solubility and its temperature. Because it's not always that if you're having a substance, as you increase the temperature, you are going to have its solubility increasing. There are some of the substances that if you increase its temperature, its solubility is going to reduce, regardless of it being a gas or a solid. So now let's try and talk about the relation between it. Generally, when we are talking about solubility, we deal with gases and liquids. And we know that if you are increasing the solubility, if you are increasing the temperature of a solution, we expect it solid. So you are having your solubility and your temperature. Let me put the solubility here. So you are having your temperature here and your solubility. Now, remember that the more you increase the temperature, the more it becomes soluble. So in terms of solubility, if you are having your temperature and your solubility axis, remember that if you are increasing the temperature, we expect for solids. So let's do this one for solids, and also we are going to talk about the gases as well. So for the solids, if you are increasing the temperature, this is a typical line, or this is a typical graph that shows that if you are increasing the temperature, we expect the solubility to also increase. For instance, salt, some of the salts that we are having, KNO3, which is the potassium nitrate, it is actually a salt, and it follows this trend. It's a salt which is solid, because if you are increasing its temperature, then its ability to dissolve more in a solvent also increases. There are several salts, and also there are several salts. Most of the salts obey this rule. There are other salts like NaCl. For NaCl, its trend is not as steep as compared to the KNO3, and there are some of the NaCl, which is a common salt. This particular salt, it doesn't really follow the solubility rule that the more we are increasing the temperature, the more it becomes soluble. For this, the line is actually gentle, or its slope is actually gentle because of some factors. Remember that NaCl is actually a salt, an ionic salt, of course. So because of its lattice structure, for NaCl, because of its lattice structure, you are going to realize that the hydration energy is the same thing as the energy that is required to break the bonds. So if you are having your hydration energy being equal to the same amount of energy that is being required to break the bond, then we actually expect the solubility of this to remain constant or be at a gentle slope, because no, regardless of the temperature that you actually increase, is the same amount of energy that's also obtained from the water molecules or the solvents hydrating the ions. Remember that if you dissolve NaCl into water or into a solvent, you are going to get its ionic components. And here you can have your hydration energy being formed because some of the water molecules are going to surround this particular ions, allowing you to get hydration energy. And from experiments, we've realized that some of the or most of the hydration energy is equivalent to the energy that is required to break the bond. So the more you increase the temperature, you are not going to see any appreciable change in its solubility for NaCl. Now let's try and talk about the solubility aspect for gases. The gases actually obey a different trend. The gases actually obey a different trend, where the more you are increasing the temperature, the more it decreases in solubility. Now, considering the same thing for temperature and solubility, the more you decrease the temperature or the more you increase the temperature, the lower So you can have something like, let me put the solubility rather here. Let me put the solubility here so that it will become very simple. So putting the solubility here and the temperature here. This side represents an increase in temperature, while this side represents an increase in solubility. So if you are having a gas like carbon dioxide, and from here you are going to use this carbon dioxide to explain some of the concepts. For instance, carbonated drinks, for instance, why its solubility decreases when you are increasing the temperature. So this is a typical example of gas. So if you are having a gas, the more you are increasing its temperature, the more you are actually decreasing its solubility. Carbon dioxide is a typical example. If you are having your carbon dioxide and you actually increase the temperature, for instance, the carbonated drink that I'm talking about, let's take the normal drink that you know, for instance, Coca-Cola. So if you're having Coca-Cola is actually a typical example of drinks that are being carbonated. Carbonated means we have dissolved some amount of gases into this particular drink. So if you've realized, if you're having a chilled drink, a chilled carbonated drink, if it is very chilled and you open it, you're not going to realize that some of the gas, you are not going to see the physics of the gases actually coming out as compared to you having a warm carbonated drink. The moment you're having a warm carbonated drink and you open it, then you tend to see some of the physics of the drink coming out, showing that most of the carbon that has been dissolved in the liquid is coming out. So the more you decrease the temperature and increase the pressure. So for gases, please take note that for gases, it's not only about temperature, but also for high pressure and low temperature, you are going to have more of the gases dissolving in liquid. So if you want to dissolve most of the gases in liquid, if you are in an industry where they produce a carbonated drink and you are having an idea about solubility, if you want to dissolve most of the carbon dioxide into these liquid drinks, you have to actually do it at a very high pressure and a low temperature, because we don't expect most of the gases to come out. Then you have to obey these conditions, because you can also try it where you are having a carbonated drink. You buy a warm one and a cold one. You open the two bottles and you see the one that will be producing most of the gases. If it is producing most of the gases, it doesn't mean that it is dissolving most of the gases, right? But if it is producing most of the gases out of the bottle, it means that its solubility in the liquid has decreased because there's an increase in temperature. So now let's try and talk about some factors. Now that we've talked about the two main factors, which is the temperature, and also we've talked about the two main factors. One is the temperature. Now let's try and talk about the other ones that affect solubility of a substance. For solubility of a gas, the two main things that really affect it is the pressure and also the temperature. But for solids, we are having a lot of factors. We are having several factors that affect this solubility of solids. Solids that we actually take into consideration is the salts. So for solids, factors that affect we are having temperature. And why are we saying that temperature is a factor? Temperature is a factor because if you increase the temperature, you are going to increase its solubility. And why are we saying that if you increase the temperature, you are going to increase its solubility? In the molecular level, or in terms of the kinetic energy of the particles, if you are increasing the temperature, we actually expect the kinetic energy of the molecules to actually increase. And if they are increasing, collision occurs, which results in breaking of their bonds. So the temperature, one, it breaks the bonds. It breaks the bonds of the solid. And also, two, it increases its kinetic energy. So if the kinetic energy of these particular solids is being increased, then the rate at which they will dissolve in the solvent also increases. So its kinetic energy also increases. Now, let's talk about the second part. Because we're not talking about gases. In terms of gases, then that's why we include the pressure. But in terms of solid alone, then we are going to have the nature of the solute or the solvent. Now, in terms of the nature of the solute and the solvent, for solvents, you realize that if for something to dissolve in the other, the solvent should have the same properties as compared to the solids. You can't dissolve an ionic compound in an organic solvent and you expect it to dissolve. No. So the type of solvent or the nature of the solvent also counts as compared to the nature of the solute as well. Then in some cases too, we also talk about the surface area of the solid. In terms of solid, we talk about the surface area because if you are having a rocky salt, let's talk about the surface area for instance too. But it's not actually a main factor that affects the solubility. If you are having a rocky salt and you are having an iodated salt means this salt is actually fine. They are fine in nature. They are very small. But this rocky salt, they are large. So if you are having these two and they are dissolving in a solution, this does not actually affect the solubility. But all what I want you to know is that you are going to have this iodated salt dissolving more or dissolving faster as compared to the rocky salt. It will take a lot of time for these bonds in the rocky salt to be broken down as compared to this. So the greater the surface area, of these solids, the greater it or the faster its solubility. Have you think about stirring too as well? For stirring is actually a factor, but it's not a factor that affects the solubility. It actually affects the rate at which the particular solid dissolves in the solvent. For instance, if you're having a solvent that can dissolve only 12 grams of salt, let's talk about the stirring part of it. So the stirring, if you are having a solvent and this solvent can only dissolve a maximum of 12 grams of salt, the same solvent to here as well, it can also dissolve 12 grams of salt. Remember that if you should add all the 12 grams, if you're having 12 grams of, let's say, a rocky salt, if you add this rocky salt to the two, and one, you are stirring it, the other one, we are not stirring it, at the end of the day, the solvent will be able to dissolve these two or rocky salt. It will be able to dissolve it completely, just that one will dissolve faster as compared to the other one. But that does not necessarily mean that what it is going to what dissolve more. If you are stirring, it is going to dissolve more as compared to the rocky salt. No, that's not what happens. So stirring is actually not a factor that affects the solubility of a particular substance, but rather it affects the rate at which what the particular solvent, the particular solute dissolves in the solvent. Now, let's try and talk about some solubility rules. In terms of the solubility rules, there are a lot of things that goes into it. For compounds that are, if a compound should be soluble, if you know the solubility rules, then you'll be able to predict the nature of what a particular solid, whether a precipitate is going to be formed or a precipitate is not going to be formed. So, in our next chapter, we are going to talk about solubility rules. In our next chapter, we are going to talk about solubility rules, where it will help us identify whether a particular compound is soluble or insoluble. For instance, if you're having a compound and you are saying that this compound is soluble, then the compound must contain one of the following what? Cations. If a compound should be soluble, it should contain some specific cations. And also, if a compound should be soluble, it should also be bonded to some particular what? Halides. Halides like chloride ion, bromide ion, iodide ion, and except for let's say silver, there are a lot of rules that goes into solubility. So I expect everyone to also go through the solubility rules bit by bit and understand the nature of some particular solids, whether if you have it in a particular reaction, there is going to be a precipitate being formed or there is no precipitate being formed. It all accounts into the solubility rules as well. So I'll see you in my next chapter of the video where we are going to talk about solubility rules more.